You good? All right. So our so our poster was on the effect of electrolytes in the development of efficient lithium-sulfur batteries. So how a battery is created is it has a cathode, an anode, and an electrolyte in between them to allow conduction, or like to allow voltage to run through. So our experiment was basically testing different ratios of these electrolytes, different types of electrolytes. We had DOL, DME, and PEGME, which they're written on here. So it's dioxylene, dimethyl ether, and polyethylene glycol dimethyl ether. We also took two different salts. We had PYR14 and I'm not going to read all this out. I don't know. Yeah, and lithium nitrate, right? So we just basically threw in a bunch of different ratios and tested the batteries. And as we did this, we you want to go through methods? All right. So we tested different mixtures, and then to make the to make the electrolyte, we took 2.5 for one of our electrolytes. We took 2.5 milliliters of DOL and 2.5 milliliters of DME and mixed them together. It's basically a 1-to-1 ratio, and then we transferred it into this glove box, as you can see here. We also added our salts in there to allow the potential voltage to be created. And then to create the battery, we have this picture here. It shows we have our anode, then we have a spring, a spacer, our anode's here, cap, spring, spacer, anode, then we have our electrolyte paper, which we dipped in the electrolyte, and our cathode, and then the top terminal to close it off. We basically put all of this together, compressed it down, and then we put it into this machine, which basically runs cycles of charging, discharging, right? So when we ran our DOL DME with the both salts in it, we found out that this was our cycles over a certain number of time. The potential voltage seen here is about 0.004. So what this means is, like, for a battery that's lithium sulfur, right, it should be gravitating around 3 volts. So when we put this electrolyte in, the amount of voltage that we use is only 0.004. So instead of it being at 3 volts, it's technically at like 2.996. Okay, now the other one, as you can see, the potential voltage, it's kind of hard to read here, but it's around 0.2, gravitating from 0. So what this means is that the 3 volts is actually going to go to 2.8 due to like loss from friction or loss from, just energy is being lost with that electrolyte. So this one's obviously better. We then ran it with a graphene chloride cathode, which is basically a lithium sulfur battery, and it also showed that it worked pretty well. Like, we got up to 3 volts and we got down discharge to 1.5, which is what should happen with that battery.
You guys' paper is on the USB, right?
On what?
The USB that they gave us at the beginning?
No, we didn't do a paper. Or, well,
this is like all the...
It might be. I don't, like, maybe the abstract, that's what we sent out, so hopefully. Alright, and then the conclusion was basically that we ran lithium batteries. Now when we run these lithium batteries, you're able to only see the potential voltage because it gravitates around 0 instead of like the 3 volts with something else, you know what I mean? Because there's no power, it's canceling out. So when we did this, we were able to see the DOL DME was better. We were also able to see that when we tested it on an actual battery, it was pretty good. So, I mean, it shows potential. Like, you know what I mean? It's
so you guys are adding another...
basically, this electrolyte, yeah, we're basically just doing different mixtures now. So we're running different things to see if we can get the conductivity to be better without losing energy. Because the problem is, an anode and a cathode, the way it works is it'll like transfer electrons through here. So when it does that, you kind of lose some of the energy. But depending on what the electrolyte is, you can lose more energy or less.
You should minimize that.
Yeah, and that's like basically.
And you said that it was this one,
the DOL DME with the LiTFSI anion. So the LiTFSI and the LiNO3, these are salts. We found out, like, when you add these salts to it, it actually conducts a lot better. You know what I mean? So
why does it conduct better?
That's the thing. We're still looking into that, but like we just finished this like recently. So.
Okay, cool. Okay,
yeah.
cool. I mean, like I said, I'm gonna write a
paper.
Yeah. So
no, I get
what
it.
are your references? This is your references right here, right?
Yeah, that's our references. That's what we use.
You guys like
we used like previous.
studies?
Yeah. We actually looked up different articles on the different mixtures that we use. So we looked up like, oh, some people are like, oh, this mixture's great, try this mixture's great. We took those and we basically like made a Frankenstein mixture out of them, like throwing a bunch of them together to see what happens, and we found one that's pretty good.
Cool. Thank you. Appreciate it.
Alright, no problem. What's your name?
Gustavo?
Nathaniel.
Nathaniel.
Awesome.